densely tickle. The fuels used were liquid oxygen and alcohol. The rocket was launched vertically, and as soon as full thrust is applied, it rises from the ground and then gradually turns over by means of automatic instruments controlling the rudders until it is pointing at an angle of approximately 45 degrees towards its target, when the rocket motor is cut off. The rocket then continues under its own inertia to its maximum altitude of about 56 miles, then falls in a natural parabola towards its target. A maximum range of just over 200 miles was obtained. Some pictures are shown of two failures at launching. In the first case, the rocket became unstable during its upward flight and turned over, causing it to return to Earth. The rocket landed on a German aerodrome. Its done can clearly be seen. On this occasion, the rocket toppled before takeoff, causing the fuel tanks to explode. Finally, here is a launching during the Operation Backfire at Cuxhaven in November of 1945. The rockets in this case were fired into the North Sea. The X-4 was designed as an air-to-air weapon for fighters attacking large bomber formations. It is a remotely controlled rocket projectile, the control signals being transmitted by two spools of wire, each 1 kilometer in length, mounted on the wings of the missile. These spools may be clearly seen here. The missile is powered with a BMW nitric acid motor. As it proceeds towards its target, it rotates, slowly winding the two coils of wire into one. This picture shows an X-4 mounted on a Focke-Wulf 190, and pictures of it in flight are also shown. The method of filling the motor is shown here. First, amine and secondly nitric acid are filled into their respective tanks. Here is a stat test on the X-4 motor. The HS-298 was another rocket-propelled air-to-air missile with a range of 2.5 kilometers. It was to be launched from rails on the parent aircraft and guided to its target by radio control. Experiments were also underway to develop a direct wire control for this missile. These pictures show the method of mounting on an aircraft, and the VT fuse and generator can clearly be seen in front of the missile. The generator supplies power for the radio receiver and controls. Among the guided anti-aircraft missiles employing liquid fuel motors under development by the Germans was Enzian. This missile, which resembled a small aircraft, was launched from an inclined ramp on a modified 88mm gun mount and achieved a maximum speed of 850 feet per second. It was fitted with a nitric acid motor and employed 4 solid fuel assisted takeoff units which were jettisoned when the fuel was burned out, that is, after approximately 5 seconds. The missile was controlled by radio link and fitted with a proximity fuse designed to operate within 170 yards of the target. These pictures show the arrangement of the combustion chamber and the servo motors operating the control surfaces. The missile is placed on the ramp while it is in the horizontal position, and the ramp is then elevated by hand cranking to the required takeoff angle. These pictures show a water test being carried out to test the fuel tanks and system for leakages, but this would not be part of the standard launching procedure. Is the HS-117, known as Schmetterling. This is than the one previously seen and employed a nitric acid motor developed by BMW. This missile also employed 2 solid fuel assisted takeoff units, which were also jettisoned when the missile was airborne. It will be seen that the operation of conveying the weapon to the firing point, raising it and placing on the ramp required only 2 men. This rocket was designed to be able to destroy a flying fortress when it exploded within 25 feet. Its ceiling was 25,000 feet, and its speed governed 27 miles an hour, irrespective of altitude. Here are some pictures of test firings of the Schmetterling. The reason for the peculiar rotating motion of the missile is not known, but it was deliberate and was later dispensed with. a static test of the HS-117 nitric acid motor. Fueling the nitric acid motor was a relatively simple task, the fuel being brought to the fueling point in this tank wagon and the fuel being passed into the motor through appropriate fueling points. Wasserfall is a supersonic guided anti-aircraft missile intended for the attack of large bomber formations. This rocket is actually a scaled-down version of the A4 with wings added, although there are slight differences in the two rockets. Wasserfall employs a nitric acid motor, and the fuels are fed into the combustion chamber by means of compressed gas instead of pumps. The rocket was required to be able to destroy an aircraft flying at a speed of 560 miles per hour at 65,000 feet. Its maximum speed was estimated at approximately 2,500 feet per second. This is the control apparatus, part of the Rhineland system, being tested prior to launching of Wasserfall. Although for rocket motors requiring ease of control and long burning, liquid fuels are always to be preferred, there are still some applications for solid fuels. An example of this is the Rheintochter guided anti-aircraft projectile. This missile was developed by Rheinmetall Borzig, but was still under development when the war ended. These pictures show the first firing trials of the Rheintochter. The first test was to check the stability of the missile once it was airborne, and it will be seen that a considerable degree of stability had been achieved. In this particular test, the boost unit at the rear does not separate. Another trial to test the rotary controls. Again, the boost unit does not separate, but it will be noted that the missile is very slowly rotating whilst in flight. Another trial, this time to test the stability after separation, and in this test the boost unit will be seen to separate from the main projectile. Another application of solid fuel motors is the rocket-assisted armor-piercing bomb used in 1941 against shipping in the Mediterranean area. These bombs were used exclusively by dive bombers, where the low release altitude does not always enable the bomb to attain sufficient velocity for piercing armor. When dive bombers went out of action, so did these bombs. This is a later development. A spherical bomb is released from a fighter and increased in speed by a rocket. When the bomb strikes the surface of the sea, the bomb separates from the rocket and bounces along on the surface of the sea for a considerable distance. The idea was that when the bomb struck a ship, it would sink, and a hydrostatic fuse would cause the bomb to function at a predetermined depth. Another drop, again illustrating the effect of the rocket in substantially increasing the forward speed of the bomb. Now we have a test where two bombs are dropped simultaneously. In this case they are not rocket assisted. Here the bomb will be clearly seen toward the end of its run. Another test with again two unassisted bombs being dropped. At the end of their run, the bombs will sink, and the hydrostatic fuses will operate, showing the extensive effects of this particular bomb. Here is what must be the last word in solid fuel rockets. A four-stage, ground-to-ground, long-range weapon, the Rheinboter. Also still under development by Rheinmetall Borzig at the end of the war. A range of 90 miles was calculated for this weapon, but it carried a warhead of only about 56 pounds. The firing trials show that some success has been achieved from a technical point of view. The first stage, having burned out, is seen to fall off, followed later by the second stage. Finally, here is what may well prove to be a more peaceful application of the rocket as a power unit. In this case, two solid fuel rockets are used to enable a glider to take off in mountainous country without having to use any complicated takeoff apparatus. The rocket motors consist of a single solid stick of fuel and give a thrust of 400 kilograms for approximately 6 seconds, and this gives the glider sufficient impulse to carry it for about 25 miles. The takeoff is seen to be quite easily accomplished, and the glider rises from the ground quite swiftly. Here is a static test showing the operation of charging and initiation of the motor. This, therefore, brings us right up to the present day. But what of the future? Werner von Braun, the chief engineer of the A4 long-range rocket, obtained his ideas and enthusiasm for this project from Nabel and Obert, who, already in 1932, clearly visualized and predicted this development as a stage in the ultimate construction of a spaceship. The A4, which was first put into use by the Germans in 1944, represents the greatest advance in rocket technique. Here is the rocket, weighing over 12 tons, of which 8 tons are fuel, starting out on its journey, which will take it to an altitude of 300,000 feet, ending with the missile crashing on its target at a speed in excess of 3,000 miles per hour.